Hello, my name is Dennis. I'm going to present a talk that's called Routing with OpenStreetmap Data. What I'm going to present is partial joint work with Christian Fedder, who unfortunately can't be here. But I managed to break a day free of my schedule and going to present here what we did with the OpenStreetmap data regarding to routing. So first, I'm going to present a solution that Christian worked on that's called Monav, abbreviation for mobile navigation. It's a routing service implementation for mobile devices. And it runs also on desktop PCs. It's sufficiently fast. It delivers routes on mobile devices within about 200 milliseconds of time, which is usually much faster than commercial devices that you have in your car or on your handheld devices. It also features a route planning service. When Christian began his work, he started it at a master's thesis at our research institute. And he worked on fast route planning on mobile devices. What he did so far was a basic implementation that featured a quite rusty UI that used pre-rendered tiles, took up a lot of flash space, but still was the fastest around when compared to most devices that are available on the market. What Christian implemented was a sophisticated address search that was superior in many regards when compared to commercial devices. Since then, the GUI has improved a lot. So what we see here is the main interface of his mobile implementation. He features downloads of prepackaged maps. He has a nice and neat UI nowadays. A lot of people have joined the project since it went public in the past year. I believe there are at least 5 people working on it regularly now. It has improved in many ways. What's really, really interesting is a feature called map management. It supports multiple maps that can be downloaded automatically, or more or less automatically. You have to activate the download. You can select which area you would like, for example, United Kingdom and Ireland, or France, Germany. It also pulls updates automatically. Really, really nice. It gives you routing on a mobile device with the updated data. The best development that's taking place right now is working on vector rendering. You don't want to have pre-rendered tiles on a mobile device because the tiles eat up a lot of flash space, and flash space is always scarce. And storing the data as vector data and doing live vector rendering is much more important. So what we see here is the early development version compared to pre-rendered tiles with Mapnik. And what we see below is the Mapnik tiles. You see lots of annotations like street names, like parking lots, like bars. We see a medical clinic here as well, and so on and so on. And in the development version, we see a lot of the geometry already. So what's still missing is annotation of the data. And there are currently 2 separate modules that are work in progress. One is based on libOSM Scout, and the other one is based on the Qtile renderer. Both modules look very promising, and we're fairly certain that in more or less short time we will have a really, really nice solution as well. What Christian also worked on was turn instructions, which are very important if you have a mobile device. You'd simply want to know when to make a turn. And right now, we look at the screenshot, you say, I'm at this position, and it says, OK, I should continue on the street for a couple of meters and then probably do a turn. And at the moment, it's more or less text-based. An obstacle was to get rid of instructions like do a U-turn. Usually, drivers in the car don't want to do U-turns at all. Only when it's absolutely necessary, which means you have to be stuck and have to do it anyway. So this is really a nice feature of Monav. Monav was one of the first tools to support PBF, which is a really, really nice format. Compared to the usual XML, it's much more, much easier to use, much more efficient with disk space. The reading times are much faster. You have much smaller files. It has, on the other side, the same information as the original XML files. And yeah, as the last line states, Monav had really early support for PDF, which was September last year. And when you want to use OSM data for a routing engine, PBF has become the de facto input standard. Another nice feature of Monav is it also runs as a background service. Monav itself is GPL, so it's a via license. But you have a distinct routing service which is also GPL, but has a LGPL interface, which makes it easy to integrate it into any service or product that you want to build. Right now, it's already used by KDE's Marvel, and really works seamlessly with Marvel. It's a really nice user experience. We have a few screenshots here. We have a link. If you're interested in it, have a look at these links. The slides are going to be published. And Monav has many, many improvements still to come. Version 0.3 was released a few weeks ago, if I remember correctly. Just download it, use it for you as a end user. It will give you a really, really nice experience. You will see that the things Monav has to offer are very rare that what you usually have to buy for a couple hundred of bucks. For developers, Christian is still looking for fellow developers who chime in, and also testers. A large obstacle right now is if you have a large code base of a few thousand lines of code, you really, really need people that are going to test the code and also have a quite technical background who can report in a technical way what the problem is. And also, think of it, the routing service is LGPL, so it really can be easily incorporated into any other software product. Going to present links on Monav at the end of the talk, so don't fear, you're going to get the address. Part 2 of my talk is what I'm working on. And I'm working on OSRM, which is short for Open Source Routing Machine. And it has quite a different focus. I'm working on server-based routing. Server-based routing needs query times that are much below the 200 milliseconds on a local device. What you want to have is you want to be really, really fast. You want to serve queries in real time. That means, including network transfer, you usually want to do it below 100 milliseconds. So below 100 milliseconds is, well, it's the usual threshold that you read in the literature that people are not going to distinguish any lag between query and answer. What we have right now is we have these fast queries. I'm going to compare this with a graph that I found on the blog later. We have a very nice but still simple Ajax UI, so you can use it on your own machine. You can use it on a demo service. It's fairly sophisticated right now. We have approximately a few thousand lines of code, 7,000 lines. A little bit below, it's like 14 lines less of 7,000. And I thought yesterday, should I commit again 14 lines of comments? So I beat the 7,000, but I didn't. I'm going to do this next. So this is a slide that shows the first 12 months of support, of development. And this is a typo here. It shouldn't say die, but the first 12 months. That happens when you translate a slide from German to English. So what we did in March 2010 was we had the initial development where we had a basic algorithmic core ready. We released about a year ago version 0.1, then went into a bug fixing period, which is which was a time of a few hours of sleep and lots of coding. And at the end of the summer, we were able to work the entire planet on a fairly commodity machine. So nothing fancy here. Then we started with supporting different things. We had an HTTP component, which got upgraded later. We had PBF support as well. We had a website. We had turn instructions. We had another release. And if we look into the past 6 months, we will see a lot more features. We had an Ajax GUI that was contributed by a fellow developer. We had draggable routes, which means we were able to drag start and end of routes in real time over the network, and not only the local network, but the internet. I'm going to show in a minute that we also have draggable via points in real time. We had user features like permanent links. You have a route, you click a button, you get a permanent link for that route, so you can distribute it by email to your friends. We had several output formats. We already deprecated the first one, which is a KML. The standard output format is JSON, which is easily possible. We had compression. We had encoding of the route data. We had route generalization. And this is only the bold points. We had many, many changes. We have an online demo running, hosted by our friends at Geofabrik, who provided the server that's running the engine. And you can have a test drive yourself, map.project OSRM.org. We had lots of public attention. When we went live with the service, we had 250,000 routes within the first 2 weeks. So we attracted a lot of public attention here. We are proud of that. We're also very proud that the server didn't crash at any point in these 2 weeks, running very, very smoothly, serving these users with ease. So if we had, I don't know, tenfold numbers of users, that would have worked as well. So to put it in perspective, 250,000 means routes, not necessarily 250,000 distinct people who accessed our service. It's more like 2,500 people who accessed it and did lots of route computation. If you have draggable routes, you can easily start, I don't know, 10, 20 queries within half a minute without even knowing. So I'm going to show an online demo right now, which I prepared because I didn't know if I had internet connection here. And I'm also going to present a better feature that's not yet online. You are, depending on where you're sitting, person number 4 who's going to see this. I'm going to present draggable via points. So what we see is we input start and destination of the route, click route here, it's instantly there. We zoom out a bit. We have a rather short route here, it's only 3.5 kilometers. long. When we get close to the route, we see a little icon that's going to indicate where we're going to grab our route, grab it, put it somewhere else, grab again, put it somewhere else again. The turn instructions are updated accordingly. So we can also delete wire points very easily, recompute the route. All in all, you have seen about 35 routing queries right now. So that the short links I was going to talk about, you can also get a GPX file of the geometry directly downloaded. All this was done over the internet. So it's a fairly live setting. So let's get back to the talk. All right, what does the public say? What I found on the internet was last week was this slide of a user / fellow developer who prepared this. It's be careful with it. It's comparing apples and oranges. It's giving the seconds of the query time on this axis and, let's say, a distance here on this axis. So all routes start in Berlin and going west and even more west and until we reach the ocean. What we see here is that we have really good query times. Very proud of that. Very much appreciated. We are doing better than others, or fairly the same as others. But one has to put this in perspective. We have a limited data set only running on Western Europe. We don't have a continental size or world size road network running that probably one of the competitors is running. But we also, on the other hand, don't have any infrastructure. So it's a virtual server where the thing is running on with I don't know what CPU. It's a virtual CPU. No idea what's really behind it. But what we can take from this picture is that the routing engine has a lot of potential. And right now we do not have all the features, but going to develop this. The general testimony is project is great, but still is stuff missing. What's coming next is we want to use less RAM, we want to get faster, even faster, we want to have alternative routes. Several other things like turn restrictions, which we do not handle right now. Multiple metrics, so we can do not only car, but also pedestrian routing, bicycle routing, and so on. Not going to go into details yet, but the problem is it's still a spare time project, so things will take some time. All right. Are there any questions?
Okay, so we have a few minutes for questions left. So there's one in the background.
Thanks.
Yeah.
Hi. How do you estimate travel times, and to what extent do your estimations agree with other routing services like Google Maps?
How do we estimate what times?
Travel times.
Travel times. Yeah, guessing travel times is a bit of black magic. We used the travel times that we found on a website, I believe on the wiki of OSRM. It's estimated travel time on some average speed, depending on the category of the road right now. But that can be changed easily.
So another question. Yeah.
Hello. Hi.
Hi.
What do you use for geocoding?
Right now, it's MapQuest, I believe. But we're going to change that as well. Have our own geocoding running.
Can you say what you're going to change it to?
Algorithms that were developed at the research group where I work.
Excuse me? That were developed where?
Algorithms that were developed at a research group where I work.
Okay, thanks.
Hi. With the web routing, is the API developed? So say I wanted to develop a custom web application with your routing. Let's say, I mean, to take an example of something that I'm involved in, the route to your nearest park, as in your nearest leisure equals park. Would it be possible to write a custom web app using an API, using your API?
Yeah, it's pretty easy. We have an HTTP API. What you basically give is the coordinates of origin and destination and possible wire points, and then you get the route.
And if we wanted to run it on our own server, would we be able to write a C++ CGI program which uses library calls for your routing engine?
Well, that has to be developed. Right now it's plain HTTP calls.
Yeah. That's fine. Thanks.